Welcome to Emilak online tutorial. Now before us is this question. It says, due to friction, a force of 400 Newton is needed to drag a wooden crate across a smooth floor. Now the rope tied to the crate is held at an angle of 60 degrees with the horizontal. How much tension is needed in the rope to move the crate? Now what work is done if the crate is dragged? Now let us horizontal ground. Now here is the crate, and a force of 400 Newton. Okay, and to this end, we are told that the rope tied to the crate is held at an angle. So let's say this is the rope, then 60. Now I say due to friction, so I do just put that one. Here you have the frictional force acting opposite, and here is the tension, right, on the rope, or rather in the rope. Okay, so now if you take a look at this triangle, that's this tension. Here you have the tension, we have the force, we have the what? Angle. Now the relationship between the force, the angle, and the tension. You see, this is the hypotenuse and this is the adjacent. So here you have cos theta, then equals adjacent all over hypotenuse. So to this end, adjacent is cos theta, that is 60. Then adjacent, that is the force. Then all over hypotenuse, the tension. So to this end, making the tension the sort of relation, we have that T will now be equals to force all over cos 60, and that will be 400, and cos 60 should be 0.5. okay, and that's the same thing as 1 over 2 to give us 400 divided by 1 over 2. Then here we have 400 times 2 giving us 800 Newton. Now for number 2, what work is done if the crate is dragged 25 meters? Alright, now for work, which is what, force times distance. So to this end, our work here, then the force is what, 400 times 25. Okay, alright, so there we have 400 times 25. 4 times 25 will give us that will be 1000. No, that will be 100. Then the remaining 0, 1, 0. So here you have 1 times 10 to the power 4 joules. Alright, thank you. Now let us look at this question again. And here it says a force of 600 Newton is applied to a metal box to pull it 15 meters across a smooth floor. Now the rope used to pull the box is held at an angle of what? 45 degrees with the floor. Okay, how much is the work? Now let us give a pictorial diagram of this. Now here's the floor. Now this is the box, right? Okay, here is the box. Okay, now and we are told now a force of 600 Newton is applied to the metal box to pull it 15 meters across on its. So the distance, let us assume from here, let's say down to this place, is 15 meters. So take note, this is not drawn to scale. Okay, And we are told here that a rope, okay, which we apply. Now the rope used to pull the box is held at an angle of what? With the floor. So which means the rope is tied somewhere around here and held this way. So the force here, F 600 what? Newton. Now the angle here is what? 45 degree. Okay. All right. And we are told now we're not giving the weight of the box, right? No. We're only giving that the force of 600 Newton pulls the box, and the distance is what? 15 meters. So to this end, our work done will now give us the force times. Now take note that this force now is projected at an angle of what? 45 degrees. So here we have cos theta, then times the distance. Let me see. Now this is adjacent A and hypotenuse. Okay, that'll be cos. Alright, so to this end now we have that the work done, the force 600 now cos 45 degrees, then times the distance 15. Alright, now cos 45 degree by my calculator now should give me, so by my calculator here we have here 600 times to be 0.7071, then times 15. So let us multiply everything together, times 600 times 15. So our work done now will now be 6,363.96. Okay, joules. Final answer. Alright, let us look at this question again. Now this is still on the work and work energy and power. Now a worker carries cement blocks weighing 150 Newton each. The block is very weighty. Now up a ladder into a what? Scaffold 8.0 meter high. Okay, now the worker carries them at a rate of 2 blocks per minute. Okay, how much work is done by the worker in 10 minutes and 1 hour? Let us give a pictorial diagram of this. Now let us assume that this is the scaffolder. Now this is the ground. However it is. Now from this top here to the bottom is 8.0 meter. Okay, and this young man let's say this is the young man here. Alright, so and that's the ladder. Now up the scaffold, and each of these is 150 Newton. So this one 150 Newton. Now in total here you have 300 Newton. And take note, always acting downward. Now since we are not told the weight of the man, so we neglect that and work on the weight of the block. Okay, now we recall that work equals to what? The force times what? The distance. Okay, and in this case here, the height of the scaffolder to which this force is acting on is the height, so we'll probably replace our D here with the height, and the force here will be the weight of this block. So let's say the weight W, and let's make this one capital W as the work. Okay, so to this end, and take note, we are told that the worker carries them at a rate of 2 blocks per what? Minute. Okay, so which implies that we're going to climb from here to this point. From here to this point is a minute, which means with these 2 blocks on his head, from here to here is 2 minutes. So for every minute, now let us calculate the work done. Now here we have, since the 2 blocks make up what? 300, then times 8, which is the height, then we end up having 24,000 joules, which means for every minute the work done this worker expel while climbing is what? 2,400 joules. Now in 10 minutes, so now this is what? Per a minute. So in 10 minutes, what we all need to do is what? 2400 times what? 10. This will give us 24000, which in standard form will be 1, 2, 3, and 4. 2.4 times 10 raised to the power 4 joules. Now in 1 hour, now let us calculate our 1 hour equals what? 60 minutes. So our B will then be 24 joules, 2400 joules times 60 minutes, which is 1 hour. So to this end, let's have it this way. This is 24 times 6 times 1000. So here you have 4, 2, then this is 12, then times 0, 1000, which will give us what? 144000. Now standard form 1, 2, 3, 4, and 5. So this will be 1.44 times 10 raised to the power 5 joules. Alright, and that is the final answer. Before us is this question under work, energy, and power, and it says a force of 25.0 Newton is needed to move a crate up a smooth incline 10.0 meter long. A. If the crate weighs 125 Newton, determine the work done. And B. How high above the floor is the top of the incline? Alright, by pictorial illustration, an incline plane is just a device that is used to aid work. Okay, now this is our horizontal ground. Now this is the incline plane that is about to be used to drag this crate. Now, and the force is 25 Newton according to the question. Okay, and here is the distance from the top of the incline down to the horizontal, and let us represent that as h. Now the weight of this crate acting downward is given as 125 Newton. Okay, I guess these are all the parameters. Okay, and it's remaining the length of the inclined plane. So from here, from this point A to B is 10. Now it's 10.0 meter. Okay, now let us make this here A, B, point B, and let us say here C. Okay, all right, now from here, and by definition, work equals to the product of the force and the perpendicular what distance. Okay, now in this case our force is given as 25 Newton. Now the weight of the crate is given as 125 Newton. Okay, now and the distance from A to B is 10 meter. Okay, now let's say our work now, capital W, okay, now equals to force times distance, and our force here is 25 now times the distance, which is what, 10. So this will give us what, 250 joules. Now it implies that this is the work that will be done if this crate, if this force of 25 Newton drags this crate from point A to point B. Alright, so now the next one, number B. Now this is number A. Now how high above the floor is the top of the incline, which means from here to here. Now since this is a smooth incline plane, okay, it implies that the work done, okay, from moving this crate from A to B will be the same thing as moving from here to here, okay, without the inclined plane. All right, to this end, we can now say that our work also will now be the width of the crate, okay, because let me write it as small w now times now the height. Okay, now to this end, our work done is what, 250. And why we make use of that, as I said earlier, that the work done in moving or in dragging this crate from A to B will be the same thing as just, you know, carrying it from here to this height without the aid of the what, inclined plane. So equals now 125, which is the weight of the crate, then times what, the height. Now dividing both sides by 125, then this will now be 125 here 1. I'm sure this should be 4. Okay, yeah, so our h now becomes what, 4 meter high. So the height from B to C is 4 meter high. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my video, and please do share this question to every other of your friends. Thank you and God bless you.